In this video, we're going to look at taking an antiderivative using trig substitution that involves a secant function. So we're being asked to evaluate the integral of dt over t squared times the square root of t squared minus 16. So I see variable squared minus constant under the radical, so that tells me that I should be using a secant substitution. However, just letting t equal the secant theta is going to give me a secant squared theta minus 16, which is not quite what we need. We need to be able to factor off the 16. So to make sure that we can factor off a 16 after we substitute something in for t, I need to put a 4 out in front of my secant so that when I square the 4, I get 16. So we're going to let t equal to 4 secant theta. So then our dt is 4 secant theta tangent theta d theta. So substituting all of our stuff in, dt is 4 secant theta tangent theta, so that ends up on top. On bottom, we'll get a 4 secant theta quantity squared times the square root of 4 secant theta quantity squared minus a 16. Alright, so one thing we notice here is that when we square the 4, we'll get a 16 on bottom and a 4 on top. Makes a 1/4, which we can pop out in front of the integral. When we square the 4 secant theta underneath the radical, we get 16 secant squared theta, and then minus the 16. Now I'm going to do a couple of steps at once. I can factor out the 16. That'll leave us with secant squared theta minus 1. Secant squared minus 1 is the same thing as tangent squared. So we'll take the square root of 16, which gives us 4, and the square root of tangent squared, which gives us tangent theta. So we get 1/4 out in front. We got a tangent of theta on top because it'll cancel with one of the secants on bottom, and then times 4 tangent theta d theta. Notice now your tangent thetas go away. We can take the extra 4 that's in the denominator, move it out in front of the integral, make it a 1/16, and then we can make the 1 over secant theta equal to the cosine. Now all we need to do is anti-differentiate cosine, and we get 1/16 sine theta plus c. We now want to go back to the original and get everything back in terms of t. Going back to our substitution, we had t was equal to 4 secant theta, or solving for secant theta, we get secant theta equals t over 4. Creating our right triangle with theta as one angle. If secant theta is t over 4, we can label the hypotenuse as t, and the adjacent side is 4, which means that our opposite side should be t squared minus 16. My apologies, that's a typo. That should be a minus sign under that square root, not a plus sign. You should end up with an expression in your right triangle that looks like an expression that you see in your integrand. So that really should be a minus when you apply your Pythagorean theorem. My apologies for that. It's correct down here in the antiderivative because now we want sine of theta, which is opposite over hypotenuse. So we still have the 1/16 out in front, so that's where that 16 is coming from. Opposite side is square root of t squared minus 16. Hypotenuse is t. And then we get a plus c on the end, finishing off our antiderivative.